Okay, Algebra 2 students, here's the first video for section 6.1, Key Features of Exponential Functions. We're going to see how do graphs and equations reveal key features of exponential growth and decay functions. In the end, you're going to be able to recognize that. And there's quite a bit of vocabulary. Decay factor, exponential decay function, exponential growth function, growth factor. Let's take a look at the first example. They want us to see what the key features of the function, including domain, range, intercepts, asymptotes, and end behavior, for f of x equals 2 to the x. When the variable is up in the exponent, that makes it an exponential function. An exponential function is any function in the form y equals a times b to the x. This one has an a value of 1, and b is 2. And a and b are constants where a cannot be 0 and b has to be greater than 0 and b can't be 1. If it's 1, it's just a linear function. It doesn't grow or decay. For f, if b equals 2, since b is greater than 1, the y values of the function increase. So if b, which is just like here it's 2, if b is greater than 1, it's a growth function. Looks like this. The domain will be all real numbers. The range are all values greater than 0. The y-intercept will be 1. They have an asymptote at the the x-axis. And end behavior, as x approaches negative infinity, the function approaches 0. As x approaches positive infinity, y approaches infinity. Okay, that might be something to do with a screenshot or so. And there should be another part to this. What are the key features of the function? Include domain, range, intercepts, asymptotes, and end behavior. The a value is 5. The b value is 1/2. So this time the b value is less than 1. So let's see what's different about this one. Since the b value is less than 1, it's a decay problem. It's coming down. The domain is all real numbers still. The range is still values greater than 0. This time the y-intercept is 5 because the a value was 5. In the previous one, the a value was 1. So that's why the intercept's right there, it's 5. The asymptote is still the x-axis. This time as x approaches negative infinity, the value approaches infinity. And as x approaches infinity, the y value approaches 0. So kind of the opposite of the previous one. And now I think they're going to ask us to take a look at this function. This is not, I do not believe this is the function for this. They want you to think about it, give it a shot, come on back. What do you think? I forgot myself. Domain, range, end behavior, asymptotes, and intercept. Okay, click pause, come on back. Since it's got a 4 here, 4 is the y-intercept. So let me zoom out and move this up to 4. 0.5 means it's a decay problem, so this is right that it comes down. But I probably need to test the point out to get the exact, like let me plug in 1. If I plug in a 1 here, 0.5 to the 1 power is 0.5. 0.5 times 4 is 2. So 1, 2 is a point. So it's really looks something like that. Okay, but I didn't need to graph it to answer the questions. What's the y-intercept? 4. It's a decay problem. The asymptote is going to be the x-axis. End behavior, as x approaches infinity, y approaches 0. As x approaches negative infinity, y approaches positive infinity. And I skipped over the first thing, which was the domain. The domain are all reals. And the range, greater than 0. All right, that's it for this video. Let's take a look at the assignment. Forgot about that. Looks like you could do 14 through 17 and number 9 on pages 303 to 304. That's it for this video. Have a great day.